if you're joining from India, and if you're joining from somewhere else, then good afternoon, good morning, wherever you're joining from. Welcome to the Quantum Pulse session. Quantum Pulse is a series of sessions that QETCI has been scheduling. We are doing a session every month, and the focus is going deeper into some of the topics that are relevant in quantum today. So we are over that period where you want to talk about what is quantum, define quantum, what are the various branches of quantum. We've done all of that. So these sessions are more about a deep dive into very specific areas. And we've had some tremendous response to some of the previous sessions that we've conducted. The number of people who've been joining our sessions has been steadily growing. So looks like, the sessions are useful. But I would appreciate if most people who joined the session today can share feedback. You can write to us at info@qetci.org or drop an email to me, reena@qetci.org. I'm requesting Amukta to put all the emails there in the chat window where you can drop your feedback. The purpose of this feedback is not just feedback on this session, but in the manner in which we are conducting the session, so that we can understand what is it that you want to listen to. If you have some topics in mind, please do share that as well. So we went a little reverse here, first asking for feedback, right? Because people don't have the patience to listen to that towards the end. But I want to now take time to welcome our panelists, our esteemed panelists who have, taken the time to have this discussion with us. And the topic for today's discussion is GPS-free navigation. So we'll dive into what this is, what it means, what are the technologies, and all of that. I'm going to request all the panelists to do an introduction for themselves. As I move to you, give a little bit of give your introduction, please, and tell a little bit about what is it that you're working on in like a matter of 2 minutes. So request Mallikarjun to go ahead and introduce yourselves, please.
Hi, everyone. Hi to all the organizers. Thank you for having me. My name is Mallikarjun Karra. I'm a co-founder at QBeats. We are a full stack quantum sensing solutions company. And as is the topic of today's discussion, our chief occupation right now is solving the GPS denied navigation problem. Our method of choice is geomagnetic sensing. And in order to sense sub-nanotesla level magnetic fields, our sensor of choice is the optically pumped magnetometer. Thank you.
Sure. Aishwarya Das, over to you, please.
Yeah. Thanks so much, Reena, and everyone at QATCI for inviting me. I'm Aishwarya Das. I'm the co-founder of Dirac Labs. We are a spin-off from UW Madison, and we are working on building quantum positioning systems that essentially work in all GPS constrained environments without the need of any active signal or satellite. What we are using is a bit different from qubits. We are using diamond NV center for measuring the Earth's crustal magnetic field, and then we apply a combination of algorithms to remove external magnetic noise, and we are able to determine your position without the need of any active signal or satellite. This kind of technology cannot be spoofed or blocked, and it works everywhere. Thank you.
Professor Rajlakshmi, over to you. We lost you briefly.
Yeah, sorry. So as I was saying, so I do develop these metrology techniques for measuring small forces, for magnetic fields, various things like that. So in the process, we did develop something which measures very small magnetic field. That is the connection with with this session here. So yeah, so I will talk about more about what all this means maybe later when in the next round comes. So yeah.
And then Professor Rajlakshmi is from TIFR Hyderabad, Tata Institute.
Oh, sorry. Should I thought that was okay. Let me just repeat myself then. So yeah, I'm a researcher from Tata Institute of Fundamental Research in Hyderabad. I basically work on fundamental physics aspects of various of atom light interactions, and but for doing that we build instruments. So over the course of my career, I've mostly been building very precise instruments for doing metrology of various kind. for measuring very tiny amounts of gravity, for measuring tiny forces between atoms, or for measuring, of late, more recently, very tiny magnetic fields. And it is in that context that I am here, because these magnetic fields are, I guess the other two people also are building sensors for doing the same thing. Though there are other kinds of techniques also which can be used for this particular application. I will talk about that when and I'm given a better chance. But of course, right now, basically to tell you that, yeah, I'm basically a fundamental physics person who builds instruments. So yeah.
So both fundamental and applied physics in that sense. Yeah. So,
Yeah.
Professor Raji, in fact, I'm going to ask the next question to you only, so you can continue. We want to
Okay.
understand from a research perspective, what is the state of the art
Mhm.
GPS-free navigation, both abroad and
Mhm.
in India?
Yeah, I will come to the actual status. Before that, I'll just take a few minutes to tell you what are all the various things that are already existing in terms of GPS-free navigation. Though we are today probably will be concentrating on one aspect, but there are other things around which I think it's a good idea to say it upfront, and then we go on to concentrating on the one thing that we all three of us are kind of working on. Uh, so when you say GPS free navigation, the idea is you should be able to navigate without looking up to the satellite. So the basic ways people do this, as you can see, is I know my starting point, and from that point onwards, I just keep track of my motion, and then I should be good. So that is in that philosophy, what people use is inertial sensors, accelerometers, and basically where you add accelerometers, gyroscopes, and things like that, so that from your starting point you keep track, and then you go, and then you don't need GPS. But the problem is these sensors will this thing is called dead reckoning, and only thing is, ideally it should be fine, but the things, all of these things drift. So after a while, what you think where you are may not be exactly where you are. So you need to do something to correct. That's the problem. So there are inertial sensors. There are people who try to use sensors along with visual cues. I mean, with cameras or with ultrasound or with radar, with more terrestrial feedback to see where we are and correct course. That is one way of going about. And then there are better sensors, for example, cold atom based gyroscopes and accelerometer, which drift much less, which means that you can then correct your course without doing anything. But what the final thing I'm going to talk about is basically what we are all doing, which is to actually measure the Earth's magnetic field and use the geomagnetic field and magnetic maps of the Earth for navigation. It's in some sense it's like a more very precise version of using a compass, but this thing has some advantages in the sense that especially the kind of sensors that we are developing, this over other things. Uh, that's especially sensors that we are developing are the interesting thing that they're self-calibrating. So even if there is a drift once in a while, we can calibrate and correct for it without having reference to the outside world. One can also use other kinds of magnetic field sensors which are available in the market, like the ones which are in the phone. In fact, you can use the phone magnetometer and also do these things, but those things drift a lot and they cannot be corrected without having an actual reference magnetic field. So it is difficult to, so in the long term, if something happens, you don't know. But the systems we use are atomic systems or molecular systems, which are, there's a fundamental physics which already tells you what it is. So it is self-calibrating. So those are the systems we will be talking about. So, and then to kind of think about the global scenario, so as we already have come across, there are two kinds of those sensors, which is what the other two people are going to probably concentrate on, one on NV centers and one on the uh, atom-based sensors. So that is one thing. But one thing is true, irrespective of whatever sensor we use, a single sensor will not do the job. We will have to put a bunch of sensors, only then GPS can be avoided. Then you use them to cross calibrate and correct and do things. That is one consensus around the world which is developed over the thing. So that is one thing. And if you look at the global scene, so there are people concentrating on different things, as we just now mentioned. UK has been mostly talking about cold atom-based navigation, basically to building accelerometers and gyroscope. They have not spoken so much about geomagnetic field mapping, but they also have done some of these things. There are researchers developing these things, but not so much outside. And US DARPA has a very strong program which has been going on for almost a decade on this. And they have also demonstrated some of these things. And yeah, similarly in Europe and even Asia, especially South Korea and China have been doing this for quite some time. Uh, Everybody has started doing this using magnetic sensors and cold atom based accelerometers and gravimeters. But this thing is not come to a point where anybody can say that without GPS I can continue to navigate forever. That state nobody has reached. The demonstrations are for some short distances and it's just a capability demonstration, not really a demonstration of actual use case. The actual use case is still using only old technology with bad limits, which in which case they still need the GPS for corrections pretty soon, within few kilometers. I mean,
Right.
few tens of kilometers of that thing. That is
Thanks,
my take. So,
thanks,
yeah.
Professor Raji. I think that's very useful. Now, I'm going to request Aishwarya to talk about what is your company doing in this space. And since, based on what Professor Raji just mentioned, there are many use cases, and maybe there is a mapping of the technology to use cases as well, right? I mean, and so give us a little bit of an idea of what your company is doing and what are the kind of use cases within GPS free navigation that you are addressing.
Right. So no, as Professor Raji said, there are two types of magnetic sensors, optically pumped magnetometers and diamond NV center sensors. We are focusing on the second one. Uh, my co-founder has a PhD in this field and he's been working on it for the past 6 to 7 years. The way this sensor is different from like an optically pumped magnetometer is that we take a small diamond and we look at some of the crystalline defects in the diamond. We're able to implant a nitrogen in one of the vacancy centers of the carbon's crystalline structure, and we're able to make a very strong dipole at an atomic level. So think of it as a very strong atomic magnet. And we are sort of using that to measure the Earth's crustal magnetic field. So the reason why we measure the crustal magnetic field and why we are interested in the crustal magnetic field is because the magnetic field generated by the Earth's crust is due to two things. One is because of the presence of metals and elements in the Earth's crust and the movement of the Earth's crust over the magma. So that generates a magnetic field. Now, this magnetic field is quite small in magnitude. It's around 10 to 100 nanoteslas. So now, if you want to measure this very, very accurately, you need to have a sensor that is sensitive in the nanotesla region so that it can measure these small crustal magnetic signatures. So we sort of, map that using our diamond NV center sensors. Now, in terms of GPS, where all this is, being used, obviously one of the main use cases is that this can be used in any sort of, the closer I am to the Earth's crust, the better it sort of works. So it works very well in underground. It also works very well in sort of, underwater situations. So that's most of the applications that we are focusing on currently. And when you look at other applications where these sensors can be used, so not Dirac Labs, but there are other companies that are sort of using this for making brain computer interfaces, because you need to be able to measure the small electrical signatures that your neurons sort of fire. So diamond NV center sensors are very, very useful in that nature. How they also differ from optically pumped magnetometers is that in an OPM, you usually have a vacuum seal, and then you have some gases of like rubidium or cesium filled with it. So it's sort of, it's sort of difficult to manufacture and so on. What our approach is that we are building it on a silicon chip. So this entire sort of diamond NV sensor can very easily be fabricated in a foundry. So one of our first designs now is actually going to go to a foundry in the next 2 months in the Midwest region of US. So that's what sort of we are doing. So our focus is mostly on GPS denied navigation and also a lot of like tracking capabilities. But we are not looking at the other medical applications that a lot of other companies are focusing on. For example, Bosch in Germany is doing something in the medical field. They're working on BCIs. They're working on measuring your heart signals, magnetocardiography, and so on. But there are a lot of other applications. But we sort of want to focus on the GPS denied navigation issue because it's a big issue. A lot of capability has been shown by a lot of like other companies like Sandbox in US, Q Control very recently in Australia. But they've been only able to show this in the regions where you have very highly detailed magnetic maps available. And then there's the other class of quantum inertial sensors that Professor talked about that Inflection has sort of been able to demonstrate in UK with some of the other partners. So our sort of approach is that we want to make sensors that can be manufactured at a large scale, and we can also sort of miniaturize it. It's right now the size of like a Mac Mini, and in the next 2 years we can get it to a we can get it to a size of your iPhone, and in the next 2 to 3 years we can sort of keep on decreasing the size of the sensor, and that's when we think that these sensors can then sort of go into the mainstream technology. And similar to how every single device right now has a GPS sensor, which is either receiving GPS signals or is like giving out a GPS signal similar to like an Apple tag. That's sort of our vision, where we want to miniaturize the quantum sensor so that it can be used on a day-to-day in your day-to-day activities.
So who is your customer typically?
So right now our focus mostly is on the defense and aviation, because these are the only sort of industries that would pay right now for the premium price of the sensor. Right now it's still not at all cost comparable to your GPS sensors, or to the GPS, to the entire GPS infrastructure that is there. And that's because you spend more than $20 billion over the last 30 years to keep on sending GPS satellites, whereas the amount that has been invested in quantum sensing, and very specifically quantum sensing for GPS denied technology, is still very less. We're still we are still at somewhere around 500 to 600 million, right? So our first customers are going to be defense and aviation, both in India and US, and we are talking to these partners over there, and we've had some early conversations, and we're looking forward to demonstrate our sensors on some of their platforms sometime in the next 2 months.
Great. Over to you, Mallikarjun, to talk about what your company is focusing on, and where do you see what are the use cases that you're specifically addressing within the GPS free navigation space?
Sure.
You're on mute.
So, am I audible now? I believe so. Cases we are targeting mainly are GPS denied navigation and target detection. To this end, we have a very operation scenario specific. So our solutions are platform dependent, whether it is drones or underwater vehicles or surface vehicles. The solutions for each of these are different, and we are in the process of working with various agencies in India and abroad to do the first trials on each of these platforms. We are also an IDEX Aditi Quantum Positioning System Challenge winner that has allowed us a non-dilutive grant provided by the Indian Navy. And so we hope to go to sea trials early January with the Navy. Until then, what we are working on is mainly with drones and terrestrial vehicles, and the results have been extremely encouraging. For example, in some of our first trials in San Francisco, before my co-founder, Dr. Madhu, moved in from Berkeley, he was able to demonstrate in his car an absolute positioning accuracy of about 100 meters, RMSE. And likewise, we are currently doing with a single drone, and the next step is with a swarm of drones. Therefore, the approach is fusing multiple sensors in order to do absolute positioning as well as dead reckoning, and ultimately enhance the ability to navigate what we call outdoor mains or outdoor magnetically aided inertial navigation system. That is something that we are up to at our company.
Rina, you're on mute.
I'm so sorry. Yeah. So now if I may ask the question that since, there are some very specific areas within the GPS-free navigation space that both the companies are working on, I see a little bit of complementarity as well here. But if you look at your own areas individually, who are your biggest competitors? And what does the competitive landscape look like worldwide for you?
Uh,
So,
I'll quickly
Mallikarjun, you
address
can go
that.
first. Yeah, yeah.
Yeah, I'll quickly address that. So who are our competitors globally? I think Aishwarya mentioned that Sandbox, Q Control. There's also a bunch of stuff that Lockheed Martin and Northrop Grumman have already done. In fact, we are collaborating with TIFR, Dr. Raj Lakshmi, to also work on gyroscopes. This is really cutting edge stuff that people are doing world over. So the competition is there, but as Aishwarya mentioned, they are not fully there yet. So we are all more or less neck and neck in the race to demonstrate all-weather positioning and navigation that is highly accurate for various operational scenarios.
What about Inflection
The
Q
race is
and
still on.
the UK demonstration that was a few months ago on the ships?
The UK demonstration was, I believe, with a gravitational accelerometer.
As I said, this UK demonstration as was with a cold atom based uh, atomic interferometer and gravity gradiometer. Not really a small sensor. Uh, so yeah, that's a basically inertial sensor, not earth field mapping. And yeah. So just to clarify, I think those two already mentioned, and then I will give it back to you, Aishwarya, to answer the question. I'm not going to talk about the competitiveness. I just wanted to mention something which probably came through in what those two people said, just to explicitly say it. You see, that the two kinds of sensors they were talking about already have different sensitivities and different uh, what do you call advantages. The NV center is, as you already pointed out, can be easily miniaturized. So it can go into systems which cannot take large things. It can be light and things like that. The OPM is can be miniaturized, not at the same level as this probably, but may not be as difficult also. So both are having the thing. At the same time, uh, if I want to do the navigation sitting on Earth's field, sitting on the surface of the Earth, I need a sensitivity which is of the order of picotesla. If I want to do the same thing, I mean, nanotesla will work, but picotesla will be better. If I want to do the same thing flying from above, I need to do better. I need to have much higher sensitivity. So that's where OPMs or something like that will come in.
And yeah.
So these are all very complementary in that sense. And also, when people are talking about these things, atom interferometer can never be put on a drone. So it can be put on a ship, yes, not on a drone. It can be put on an aeroplane, yes, but not on a drone. So,
Yeah.
so these are all complementary, and as mentioned, most of the whole world is. Some people have tried a few things and they know some of the background things better, but there is no actually complete solution available today. So whoever beats the race is the can win.
That's good to know, because when you talk to some of the other companies, in fact, we had asked Q Control to be there on this panel, but somehow they could not make it. When you ask some of the other companies, many of them claim that they have ready-made solutions right now, that the solutions are working, right? So, but what we are saying is that maybe the demonstrations that have been done on the navy, on big ships with very big systems, half size of half the roof, is not something which is deployable right now or even in the future. And it's
No, it's
only
a
the final product that is going to make the difference.
I mean, Saishwarya's turn to speak, but let me just say one sentence in an answer to you, and then I will stop this. The basic deal is there are, as Mallikarjun also pointed out, there are already some commercial sensors available in the market, but these sensors can measure the magnetic field, but they cannot do mapping. So combining these aspects, nobody has done so far. That is the thing.
Okay, great. So coming to you, Aishwarya, what does the
I think it's
Yeah,
Right.
thank you.
Yeah,
Thank
no, I
you.
completely agree with both Mallikarjun and Professor. There's obviously a lot of competition Sandbox, Q Control. But there is this one company that has been working on quantum technologies for quite some time. It's Vector Atomic, and they very recently had a demonstration of an atomic gyroscope on one of NASA X plane. And this was again one of the first space, like near space-bound quantum navigation demonstration. The demonstrations that have been done right now, whether it's Sandbox, AQ, or Q Control, they're done in regions where you have very highly detailed magnetic maps. So Q Control did it in Australia because they're also, based out of Australia, and Australia also has really good gravity and magnetic maps because of the mining industry that has thrived there for the past 100 years. Similarly, even in US, there are certain states where you could do these sort of demonstrations and show that it works with a very good accuracy. But you essentially want to build a system that works literally everywhere and in all environments, and that is not yet done. Whether it's Vector Atomic, whether it's Sandbox or Q Control. So there's obviously a lot of stuff to be done there. Not like obviously the sensor, both OPM and Diamond NV center sensors, they've existed for quite some time, and they were used in a lot of high energy physics experiments and so on. It's only recently in the last 3 to 4 years where people are like, okay, we now need to build a sensor that's actually very fine tuned for the navigation purpose. And that is what even our vision sort of has been. Even my co-founder, even in his PhD, these are some of the things that he looked at. And over the past 1.5 years, our efforts have been to build a diamond NV center sensor that is tuned for the purpose of navigation and not for the other commercial magnetic field sensors that have been out there. So yeah, that's the approach that we are taking. And yes, there's still a lot of work to be done here on the software side, on the mapping side, on the denoising side, and that's some of the things that we are focusing on right now.
Wonderful. So, and taking a cue from what you just said, Aishwarya, I think it's the right time to talk about what the future of these technologies looks like. So, for example, if you were to completely let your imagination move forward and assume that some of the hurdles that you're aware of are taken care of, then what would the future of these sensors look like? What are they going to accomplish? To what level of accuracy? And what are the kind of scenarios that will play out, which you can explain in like in not so technical terms as well?
Right, and I think the scenarios are going to be fairly very like a very solar punk, cyberpunk sort of a scenario where you have all these devices that are sort of connected to each other, and they sort of know what their position is. You cannot sort of spoof the location of any enemy state actor or of any sort of thing, right? Like you don't have to be reliant on any of these active signals. Every single thing, whether it's a plane, whether it's your car, whether it's a submarine, you are able to navigate you're able to navigate each and every part of the earth without requiring any kind of active signal or satellite. Like for example, our oceans, 80% of our oceans haven't been explored because we don't have a very robust kind of a navigation system that allows us to navigate in the depths of Mariana Trench or so on. So if you have a robust positioning and navigation system that works really well and gives you sub-meter, sub-centimeter level accuracy, then you can explore the earth. And that's even better. Like you can explore all the oceans, you can go to the farthest mountains and not worry about carrying your Garmin GPS receiver to send like an SOS and so on. And obviously this entire sort of position and navigation idea extends to space as well, right? When now you're setting up colonies on moon, and now you want to go on to Mars and so on, you don't want to really spend a lot of money putting GPS satellites over there. You want to use the magnetic field of that planetary body to navigate. So this is like a very like this is what I think the future this is what I think the future of the technology lies in. Given that we solve all of these denoising, sensor miniaturization, working in all of these conditions, like you need to make sure your sensor works really well without any drift. You're able to course correct, map match, all of those things. So I think the future is it's quite interesting if you're able to solve this at scale.
Wonderful. What about you, Mallikarjun? Your thoughts on this? And then we come to Professor Raji.
I largely agree with that. To add a little more to that, I think the magic would be quantum inertial measurement units (IMUs) in space. because that would define the next revolution in space exploration. I think India included, multiple countries are taking space even more seriously than they were maybe 20 years ago or so. So as you navigate through the solar system, some of these technologies are going to be extremely critical. So basically, space defense, but also the fact is that it is defense R&D that ensures that even in the civilian domain, these technologies add a lot of value. For example, brain and heart imaging, what we call quantum MEG, magnetoencephalography or magnetocardiography. Then you've got keeping track of an EV battery's state of health. Then you can use some of these sensors for high sensitivity all band electrometry, so essentially radio frequency sensing, uh, and the list goes on and on. The ripple effects are going to be everywhere, so it makes sense to give this push initially for defense and space, and then it will be the rest of the society that reaps the benefits over the.
Right. What about you, Professor Rajlakshmi?
Hi, yes, they covered everything very nicely, but I will tell you what I would like to happen. Not that I can do it myself. That more people like Aishwarya and Mallikarjun should come forward to be able to do this. We should use these sensors so that we can replace these huge MRI machines, and I can just wear a jacket and sit somewhere quietly and get my MRI done.
Okay, so use it
So
cross usage, right? Once you develop these sensor capabilities,
yes,
it becomes
yes.
very right for
So
you.
that would be.
Hmm.
Yeah, so that would be like something. So in principle, the MRI technology can become so affordable that often these days doctors don't advise this, even though that is the best way to go for the thing, because it is more expensive and more painful. I mean, the sense of the noise and all that, not really painful in the sense of painful, it's very unpleasant. They
Right.
go to it as a last resort.
Mm-hmm.
Even though they know that the X-ray and PET scan or this thing is not going to give them the information they want. So, so that is why I think it will be wonderful if these technologies can feed into something like that, and that will actually change lives of a lot of people. So I think that would be the wonderful thing if it can happen. Yes.
Sure. Wonderful. I think there are so many applications of sensors overall, and then we're talking not just about defense and navigation capabilities for individuals also, like because cars were mentioned, but then also how some of these sensors could, the same sensors that are used for GPS-free navigation could be used in a different way with a slightly different technology for medical diagnostics, especially replacing the MRI machines, right? That would be wonderful. I wanted to touch a little bit upon the supply chain, so both on the research side and as you are, working on the commercial side, what are the challenges you face on the supply chain side? What would what is the current challenges and what is your wish list on that front? And Professor Aji, you can go first from purely from a research perspective, what are the challenges you face for your labs and stuff like that?
I think that is a common challenge, not only in this field, for all fields, because most of the equipment we need is not really manufactured in the country as of now, even though uh, there are some things we can get now, but it is still, it's more like assembling, getting things and putting together, and many people do that, and so we end up having to import a lot, and which is always dependent on moods of people, like what is going on right now with the US. So, and so that is not very nice. It also leads to other issue that lead times go up. I may have an idea today, but I will not be able to try out the idea because that one component is missing, and that one component, instead of getting it in a day or maybe a week, I'll end up taking a month, by which time I would have forgotten my idea, which is not so nice. So there is, that is one thing. So that is the main thing in terms of the supply, I mean, I don't know, you talk about supply chains, these kinds of things, but the point is to actually, this is from the researcher point of view, because for me, time scales are not important, but they are important, but still it's okay if I publish a paper 1 month later or 2 months later. I mean, nothing happens to me. But of course, if there is a student and he has to finish his thesis, that's a different thing altogether. But even so, we can do something and get somewhere. But if I'm going to do something, compete with the market outside, these kinds of things become a bigger challenge. I think that is something which those people who should be able to tell more than us. So in that sense, building up as much, I mean, of course, one person cannot make all the components required for any of these systems, but to start, while there are a lot of these companies now, unfortunately, that is also the problem of the investor. If because to satisfy the investors, of course, they have a lot to go and tell that I am making the final product, but there are lots of things going on inside. So somebody should also help companies to make only one or two of these products, things which go in, and then only things will work. This is my feeling.
Right. And I think that's the question to Aishwarya, that, in the supply chain, what are the challenges, which are the components that you feel are most lacking, which take the maximum effort, and then what your wish list looks like, what should get done in India?
I think one of the most important thing is that Indian customs should be more lenient, and allow the lasers and all the other electronic components that we sort of require. They get stuck in customs for quite some time, and then you need to file the right paperwork and get it sort of cleared, and that really pushes your timeline if you want to implement a project. So that's been one of our issues right now. Even when we want to order PCBs, there's always a delay because there's some kind of documentation that is often required, even though they know that this PCB is going to be used in a commercial setting, not for any of the other defense and military stuff, because then you have a different kind of custom clearance and so on. So I think with the startups that are working specifically on quantum technology, we do not have a lot of infrastructure over here to build it as rapidly as some of our competitors like Sandbox or Q Control. They have their entire supply chain that has been there for the past 30, 40 years. They have foundries that have been established. India right now does not have any active foundry that startups can take use of. There are few less smaller facilities in sense, and DRDO has it, but again, not really accessible to any of the Indian startups. So if we can get access to these things, it would like really we will be able to compete with these companies, and we'll be able to sort of demonstrate it much faster on a much faster time scale, because we do have the talent. There's a lot of new quantum technology masters programs that have started both in ISC, in DRDO, and so on. So there's a lot of good talent coming out of there. But if you don't have the hardware that these people will sort of use to make your device or your computer, like quantum computer or anything like that, it's always going to be an issue. And right now we don't have those suppliers in India. Those are mostly in China, in Europe, and in other parts of the world. So yeah, that's been a major issue for us, and that's why we are sort of like we do some of the work in India, we do some of the work in US, because it makes our job much easier, and we are able to deliver on the timeline that we have promised.
Great. And what about you, Mallikarjun? What are your thoughts on the challenges in the supply chain and what your wish list looks like?
Well, I think everything's been covered there. Needless to say, customs is a major pain. Um, and also the fact that, cultivating relationships with vendors across the world takes time. And so all startups have to go through that phase. Luckily for us, at least, three co-founders are scientists. Two of them bring all of these relationships with them in both the European and American ecosystems. Nevertheless, given the current geopolitical challenges, you never know what will get denied to you when. So it's great to keep all options open. But if you ask me for my wish list, yeah, I would say certainly that there needs to be some program by the Indian government in order to fast track customs clearance for startups, especially for critical technologies. Number one. Number two, I think we need to come together and understand what is it that come up with a priority list. What is that we really need and that is really going to be denied, and do something together so that all of us can reap the benefits of that. For example, one simple thing is lasers. All of us need lasers, right? You know, the more compact, the better. So who's making vehicles or so on in India? Uh, Probably nobody. There are some new startups trying,
There
but it's
are.
going
I
to
mean, I
take
think
time.
IT
So how
Delhi
about
is
efforts to
IT Delhi is
accelerate?
doing something in that space.
I know. I mean, I'm aware of Tanishq and others.
Hmm.
Yes, it's a great effort. But you know, all of these products have to be such that they can be used by us who integrate them into a final product. So you know, the ecosystem has to work together. So and once the government plays their part, I think it'll be a well-oiled machinery in maybe 5 years from now.
Right. I think it's for the startups to realize that people who are looking at starting more companies in quantum, rather than focus on, like, I mean, the number of people who are focusing on QKD is so high that I feel that if some of them were to focus on these components, they would actually make a lot of money as well. And it's an easier sell to investors too. I mean, if you really ask
Please
me,
don't give them ideas.
no, but the components that you guys require, I want to give ideas because we want more startups, we want the ecosystem to be able to do that. But the sometimes the startup founders only want to work on stuff that looks very jazzy, like a complete product. But believe me, that people who work on the supply chain components, which can be supplied to multiple entities, actually have the investors have a faster return on investment. But it doesn't look jazzy. It looks like very mundane and things that just become part of something else. But we need more
True.
startups like that in the ecosystem to come up. And I keep telling TIFR that the number of things that they have developed internally, if they can just find a way to transfer all of that, we can have some 10, 20 startups coming out of TIFR only. Because every time I visit them,
Yeah.
and the number of components.
Unfortunately, I think many of us, at least in Hyderabad, agree, but then DAE doesn't agree. We are a government funded institution, so there is a lot of challenges there. Yeah, we are
Sure.
fighting our way
Yeah, yeah,
into it to do this.
yeah,
We
and
are
we are
fighting
there
our
to
way into
support
do
you.
this, but
We are there to support you
yeah,
on
yeah,
that
but
fight.
it's
Yeah, yeah.
yeah, I think it's a little bit of a mental setup problem because we come from a setup where we build stuff and do use it for our application. You see, it's easy to say that okay, take it and use it, but then if I just give it to Aishwarya or Mallikarjun, they won't be able to use it unless I go sit with them. So that is where the problem comes. So we need to find ways of transferring the knowledge without the person getting involved. So that is something one has to do these things which we are not done in the past. So we have to start doing it now so that
But we have very good
people do learn.
examples. We have very good examples
No, no,
of
it is
how that has
no, no,
happened.
no. TIF, no, no.
Correct.
TIFR itself has many examples of how this has happened. If you go back the 25 years back in history, you will see lots of the big, good public sector companies, including CDAC, Samir, everything has come out of TIFR. Okay. So, but those were public sector companies and they knew how to deal with it.
Right.
But somehow the government mentality doesn't understand how to deal with the private.
So I was going to refer to ISRO because ISRO's program of actually transferring knowledge and IP and technology to startups, they have a wonderful program. It has been pretty successful. And I think maybe the quantum sector needs to borrow from there, is what I would say. Although easier said than done, that I totally understand. But maybe there is
Well,
something
if
to.
you can influence the policymakers, wonderful. We can't do that. So, yeah.
So coming back, I think that's a very interesting discussion in terms of what could be done in India. I also wanted to now, there's a question in the audience, and I would use that question to ask you, in each of your areas, what is the alternate technology today, and what is the sensitivity of that technology versus the sensitivity that you are aiming for in your sensors? So whoever wants to start on this.
Well, I kind of answered that in a reply on the chat. So I'll just say that, typically in regions where the magnetic gradients are low, say single digit nanotesla per kilometer, you most definitely need sub-nano Tesla sensitivities for your magnetometer. And naturally, you'll find that nobody's selling this internationally. And or if somebody is, it is export controlled. So that's what people need to aim for. For example, what we have in the lab with Dr. Raj Lakshmi is femtotesla. In the field, it is slightly lower, but that is sufficient for the requirement for the use case that we are discussing. That is, GPS denied navigation. So yes, you most definitely need sub-nano Tesla sensitivities, at least on one of the sensors in your entire sensor package.
Okay, and Aishwarya, your thoughts on your system?
Yeah, I think we are also aiming for a sub nano Tesla level sensitivity. The only sort of issue that comes in, and especially when you're looking at navigation, is that lower, like the higher your sort of sensitivity is, your error margin also sort of increases. So now you need to have a system that is able to sort of distinguish signal from noise. So you need to sort of decide what are you going to compromise on, or either your sensitivity or your denoising, and there has to be like a proper balance between the both. And I think that when you achieve that proper balance is when you'll be able to achieve the right kind of navigation, which is the RN. So there's a term known as RNP, which is required navigation performance, and that differs for an aircraft, that differs for a ship, that differs for a car. So depending on what platform you're sort of targeting, you need to reach that required navigation performance by balancing both the sensitivity and your denoising. And when you're able to sort of balance these both correctly, then you'll be able to reach your, let's say, if your desired accuracy that you need in terms of in terms of meters is 15 to 20 meters. So you need to have like a good denoiser, but you also need to have a sensor that is sub nano Tesla square root hertz, like it's sensitive at that scale. Yeah.
So I think, and what about you, Professor Raji? Any comments on that?
No, I mean, they've already basically the sensitivity is whatever what it is. So basically, yes, one does need sub nano Tesla sensitivities. And if you want to start doing things from further away, you need more sensitivity. And as Aishwarya pointed out, the basic problem is if you can measure small things, there are a lot of things which will start generating that kind of magnetic field. So you will be swamped with singular, which is not, and but most of that signal is actually it's actually signal, but it is noise for you because that is not what you want. So
Right.
then it will become a needle in a haystack problem. Your signal has become a needle now, and you don't want that. So that balance one has to be careful, and that's something which one can only train on the field. It is not something which you can do sitting in the lab, but that's where doing more and more experiments in the field and trying to understand what happens and trying to use that to improve the system is going to help.
No, so let me ask this question. Let's say we take a submarine and we take an aircraft
Yeah.
and we take drones. If I take these three examples,
Mhm.
I would assume that the level of sensitivity required is different for these three. Does everything require nano Tesla sensitivity?
Yeah, at least nano Tesla because Earth field is of that order.
Hmm.
But there are also different environments. You see, the submarine technically will have more signal because it's closer to the Earth, but it also will have more noise because it has lot more moving components, lot more things generating magnetic field.
Right.
And the hull itself is going to be a big block of metal, mostly iron, which is going to be a problem. So it has its own challenges. On the
Right.
other hand, a drone is going to fly high, but it is only going to have one motor in it. It will have less sources of noise because it just has lesser parts to it. So yeah, so that may work out better. Aeroplane will have its own sources of noise, but again, in that sense, aeroplane will require slightly more sensitivity, but you can protect the sensor from noise more easily in an aeroplane. So this is the point. So these are environments also dictate the sensitivity in some sense. It's not to both your signal and your environment together dictate your sensitivity requirement, and that is exactly why, as we already said, one sensor will not do the job. You need to have multiple sensors to distinguish between what is coming from earth or whatever it is that you're looking for, and what is coming from just things around you.
Right, fair enough. We have, I'm want to open up the this for questions because I can see a lot of people chatting here, and I would rather have these questions discussed here. So I saw a question from Aishik Acharya. Aishik, you want to ask that question?
Yeah, so actually my question is like both the technologies using NV centers or hot atoms, you use a map to existing map and use some algorithms to determine your position, right? So now if you want to navigate in a completely unknown territory where you don't have any reference, so then in that case, how do you navigate and how your accuracy will depend?
Who wants to take that question? I think
So I think both I and Sanket, we've answered in the chat. Uh, I think those two answers together answer this question pretty well, is what I believe. Uh, but yeah, essentially, what is the accuracy? That really depends. You have to do it to know. And right now, whatever we are doing, I don't think we are at liberty to reveal these things because some of the projects are with defense.
you don't have to reveal
But
this.
as an outside scientist, I can say this. Basically, again, dead reckoning is the way to go again, which means that you need to have sensors which low drifts or self-correcting, so that eventually by going back and forth in the map free region, you will generate your own maps.
Right, right. So
But
that's
until
the
then, dead reckoning is the way to go.
yeah, that makes sense. I think that sort of answers the question. And obviously, the technical details cannot be revealed. Fair enough. Any other questions? Audience, please, people who are listening, if you have any questions, please raise your hand and ask the question. People were typing a lot when we were we were in the middle of a discussion, but now that when we ask them for questions, nobody is asking questions. Okay. Can Naveen is asking, can CAI be used for linear acceleration too?
That is the whole point. I guess cold atom interferometry in a single ultra high vacuum chamber, uh, dropping atoms. That's what leads you to accelerometry. Uh, I mean, in the UK experiment, they did single axis for the gravitation. But if you want to if you really want to do positioning, even using gravitational sensing, you need a 3-axis one because you need to subtract the components due to the other 2 axes. So, yeah, the answer is yes.
And Naveen, I think you have a follow-up question. Better to clarify and ask it verbally.
The question was whether on the X and Y, horizontal X and Y, can we measure linear acceleration? Because we've seen that atom dropping under gravity, those will be measured, but if you have it on a platform that is prone to vibration, can it really be that accurate?
That is the point. So you need to know what is the platform vibration. So that has to be measured by some other thing and then subtracted. And it doesn't matter when you say gravity. It is not just gravity. It is dropping because of any acceleration. Every acceleration is equal to gravity. That is the physics of it. So it doesn't matter what is your direction of acceleration. If you are moving horizontally, that there will be effective gravity in that direction. There will be an effective G kind of a thing in that direction. So that is what the interferometer will measure. But yes, if you are the platform vibration and all of that have to be corrected for in certain levels. But you see, the atom is not on your system is on the platform. The atom is not on the platform. The atom is a gas, so it is free in that sense. But your laser light will be moving, so the vibration will have an effect. But yeah, but one needs to correct for all that. Yes.
Thank you.
I guess Aishik would be a better person to answer this question, but yeah.
Any other questions? Nitesh, can you please speak and ask that question?
Yeah, okay, I don't know, maybe. So he's just asking, does electron spin play a role in enhancing the sensitivity of magnetic sensor compared to traditional? In atomic and whatever the things we are talking about, yes, it is the electron spin. The sensor is the electron spin, effectively. Yeah. Yes, electron sitting inside the atom or the NV center for in the other case.
Okay. Yes. So any other
So
questions?
it is. Yeah. Huh?
He says, okay, ma'am. Yeah. Any other questions? So since there are no other questions, I want to give all the speakers an opportunity to share.
One question.
Yes, go ahead.
Reena, one question. Can I? In
Please
the
introduce
BCI
yourself
technique,
and ask who's speaking.
this is Naveen
Okay.
from Oxen's lab.
Hmm.
The Bose Einstein condensate based technique, has anybody achieved this one, or is it purely
No,
something theoretical?
no. Well, BEC-based accelerometers are done in the lab. Nobody is trying to take this to the field because getting a BEC is already a big deal. And then
Okay.
making an interferometer out of that will only give you marginal advantage over the cold atom based one. So you
Okay.
increased your complexity without gaining too much more. So that is why, and in any case, to get there, first you have to achieve the cold atom based interferometer. I mean, the steps are large number of
Yeah.
steps overlap, and then you need to do more
Okay.
steps in the BC. So yeah.
Right.
So I have a question now
Thank you.
for Mallikarjun. Do you see any role that AI can play in accelerating the technology, and or how are you planning to use AI in your systems?
No, absolutely. I mean, it's called machine learning, but yeah, that's the whole point. All digital signal processing algorithms, all the latest machine learning algorithms are extremely useful because this will also answer the next question. Any of your sensors, they are just sensing the ambient field as felt at the sensor head, right? Now you have to make sense of what that signal, what components it has, what is the contribution from the dipole field of the earth, what is the contribution from the crustal anomaly, what is the contribution from diurnal changes, from all sorts of sources of magnetic noise, and that is signal processing and machine learning. So yeah, AI is the heart of this entire exercise.
Anything different, Aishwarya?
No, completely same. In fact, if there are, we are hiring for a machine learning engineer at Dirac Labs for the role of denoising signals. So if there's anyone in the audience who is interested in this, please reach out to me. I'll put in my email ID at the end of this. But yeah, as Mallikarjun said, machine learning plays a huge role. In fact, over the past 6 to 7 months, we got a grant from the US and the Indian government to sort of build these denoising systems for magnetometry and gravimetry, and we have been able to show over there very considerably about like some of the algorithms that we have used have state of the art results, and now we are figuring out how do you actually use them in a field setting. So machine learning and signal processing is the missing puzzle of this entire navigation thing. Like the sensors, people have been building these sensors for quite some time, but if you're able to denoise this and map match in real time, you'll get to your place without the need of any GPS.
So Aishik has a follow-up question on that from TCG Crest. He says that as AI integration is resource hungry, especially when you're training the model, what would be your comment to mitigate swap for entire system?
So the moment you start working on this, you know for a fact that you are going to use a very a system that does not take a lot of power. So you need to build your algorithms in such a way that they are not as big as the LLMs and the transformers. You actually need to use vanilla neural network like models that then you can fit onto your whatever hardware that you're using. So that aspect is taken care of at the beginning of this, because we know that we want to be able to do this in real time. Navigation is a real time problem. You don't want to know 5 or 10 seconds later where you are. You want to know where you are right now. So it should be able to do all of this in real time. So we always take care of the model parameters, and we know that this is the kind of hardware that we are using, and we are able to do that.
Wonderful. So I think we are done with the questions. Any other questions?
Somebody is asked about which book we can read about this. I don't know. In general, about GPS free navigation, I don't know if there is a book or about, but even, see, that is the, but yeah, if you read basic books on various quantum technologies, and I think most of it just comes from basic quantum mechanics. So it also depends on what it is that you want to learn. So the book should depend on that. I mean, there's no one book which tells you about all of these things.
So after the fundamentals are strong, I think people should read papers on the latest research happening in this space. That is going to be more useful, I believe. Yeah.
Yes, but there are a lot of review papers. I think that is what will help you.
Yeah, yeah. So I'm going to request the panelists now to actually share anything that, which has not got discussed till now. If you can quickly share your thoughts, something that you want to leave the audience with in maybe 2-3 minutes, that will be great. Aishwarya?
Yeah, I can start off with. Yeah, I think one of the things that we are looking for is more participation. Like right now, with all the startups that are there in the Indian ecosystem, a lot of that is focused on LLMs and AI and so on. I think there's a exciting new field that is emerging, which is the field of quantum sensing. Quite different from quantum computing because we still have to do a lot of stuff there. Quantum sensing already exists. We use it on a day-to-day basis. Atomic clocks are used everywhere. So I think one of the important things that we would want is more people to sort of come and work for quantum technologies or like quantum sensing companies. There is a lot of hype right now for AI, and everyone sort of wants to go into it. But there are a lot of roles that we'll be hiring for specifically. So we would want the general audience to sort of take interest in that and apply for it and so on. I think there is a lot of talent that is coming out, but still they want to not explore the industry side of it. And that's why then you have to go to other places to sort of hire for. So I think they should definitely look at this field and contribute to it as much as they can.
Great. What about you, Professor Raji? You're on mute.
Sorry, I was typing some answer out here to somebody's question, but yeah. So I got a little distracted from what Aishwarya was saying. Basically, yeah. So when you say, I mean, there are a lot of challenges, and it's nice to see that there are a lot of, I think, people who are interested in learning the field and wanting to come inside. I think that is what we need. I think I'm sure Aishwarya and Mallikarjun will also agree with me. Finding people motivated to come and work in these kinds of field, because as we already see, there are various different aspects. There are physics aspects, there are engineering aspects, and there are software aspects. So there are lots of aspects to this, and one person cannot do everything, and then we need to have a team of people doing all of these things, and each one will have to learn a little bit of the other field so that there can be a cross coupling, and it'll be wonderful if a lot more people get into this kind of thing and start learning what is needed for these things, and not just concentrate only on AI or software, which are people seem to be more comfortable with these things. Even when you talk about people saying, hey, I've learned about quantum computing, it is some quiz kit or something, which is, I mean, it's still just a code. So we have to get out of that mode and try to see if we can contribute something ourselves without not just in the coding part. So it'll be nice if more people get interested in those aspects of things.
Oh, wonderful. You picked up my pet peeve. My so all the while, I've been telling people when they talk to me is that if you're an engineer or if you are a science person, you have to understand what your core skill is and what is a derived skill.
Yeah.
And coding is at the best a derived skill. You can actually train anybody to code. We've seen that in the past. You don't have to be an engineer to code. So if as an engineer you are only coding and you're good at coding only, and What are
Well,
you,
now
how are
now
you
AI
going to
is coding,
compete?
so I don't know.
Yeah,
Yeah,
exactly. So
sure.
how are you? And this issue has come. So I think trying to stay true to your profession in some sense is extremely important so that you have the differentiator. Because domain becomes very important. If I teach a doctor to code, somebody from the medical side to code, from that domain to code,
Yeah,
then that person is better off than you as an engineer when it comes to coding because he
yeah,
understands the domain as well, right? So you have to
yeah.
master your domain. And if you're an engineer, you have to exactly do what Professor Raji is saying, is to focus on the fundamentals of engineering and actually work on things like this. Join the sensing teams or quantum sensing teams, and you can always learn programming because that's a language. Just like you learn one language, you learn another one, right? So that is definitely not a skill to be very proud of because it can be replaced anytime because languages popularity keeps changing over a period of time. It is dependent on the platform and things like that. So you just picked up a subject which is very close to my heart, and I ended up rambling a little bit here, but I'll give it back to Mallikarjun. I think there's one question which you had answered, but people need more clarity, which is how are you going to compete with inflection Q because they seem to have made a lot of noise, and or are you working in a different space than them? That's the question that people are asking.
How are we going to compete with Inflection Q and others? Well, we have deals that are ongoing. We are already doing POCs for multiple clients. We have the confidence of the armed forces and the MOD, and we have some encouraging results. So I believe that once we accelerate on this and we find our own unique pathways to an end product, see, the technologies may be same, the use cases may also be the same, but the final end product that you sell to a client, that's going to be completely unique. And that's where each of us will find our niche and not just survive but thrive.
Wonderful, great answer. Uh, I
Actually,
think
Reena,
with that,
I just sorry, I just saw that somebody is asking, can we share the topics as PDF so that they can read up or something? Will you be making this AI summary or something and posting it somewhere? Then they can.
so there are two things we'll be doing. We will be actually, this video is getting recorded. It is going to be uploaded onto our YouTube channel. The second thing is that there is a transcript that is happening. So a summary will be posted as well on LinkedIn. So those are the two things that are going to happen. But feel free to watch this video as many times as you want if you miss something on the first go, and pick it up from there. And you can also go and look at some of our previous videos because all the sessions are being recorded and they are being published on YouTube. Yes, Mallikarjun, you have something to say.
Final words, we are just closing our seat round and actively hiring. We are hiring scientists, engineers, and technicians. In fact, we have about 4 people who are returning from the US to join us. So I would request anybody with plenty of experience in fields related to what we are doing to get in touch with any of us 4 co-founders, and we would love to interact with you and hopefully find a way forward.
So this is wonderful because people keep asking me where are the jobs. So one thing I have to tell people now is that you should look at the number of opportunities that have been advertised in this discussion, both from Direct Labs and from Qubits. So I think one thing is that if you want to understand about job opportunities, you should also not just understand the technology, you should join the Quantum Pulse session. This is the message to all the folks out there. But thank you for pointing that out. People often wonder where the jobs are, and they are looking at the wrong places in many cases, right? And both these companies are, please go ahead if you want to. If you have postings on LinkedIn, which you for these jobs, and you want us to share with the community, please forward that to us, and we will do that because many people are looking for those opportunities. And with that, unless anybody has anything else to say, I think we had a very good and interesting discussion on GPS-free navigation and the use of different kinds of sensors. Very rich discussion, I should say. Technically rich also from a use case perspective, and a lot of questions, very engaged audience. So thank you very much to everyone who joined. A very big thank you to our panelists for taking the time and sharing your knowledge and experience here with everyone. And thank you everyone for joining. Please do share feedback. Please share topics that you want to know more about in the emails that we have already put on the chat. So take a minute to check on those emails, copy and paste those if you want to send some feedback. And thank you very much. All right. Bye-bye.